So this exam style question was shown, the figure below shows Young's double slit experiment performed with a filament lamp as the source. So we got our filament lamp here, our source, we're passing through a single slit, passing through these double slits, and then making this pattern here. So on the axis above, they'd like us to sketch a graph showing how the intensity varies with position. So how does that work? Well, there's a couple of things here that we need to note. First of all, we need to note that basically at each point that there's a maximum, a bright fringe, there's going to be a maximum of intensity. And every time there's a dark fringe, we've got a minimum of intensity. We also need to note that the spacing between these intensities, basically what we're basically just drawing this fringe pattern, but with intensity instead. The intensity at each bright fringe is a maximum, and each dark fringe is a minimum, and the spacing between those need to be the same. There's one more thing which we're going to include here that they were interested in, but it is not always so important. That's the idea that actually the intensity decreases. The bright fringes get a bit less bright as you move further away. The idea being that the further away from the center you are, the more the light is, spread out and therefore got weaker, and so your intensity is decreased. So we will include that, but don't worry about it too much. But it is something that you might need to know, so do kind of keep it locked away somewhere. So let's just draw that out. So the idea is we get something that looks like this. We have these this constant spacing, which I know I haven't done an amazingly good job at showing. I'm afraid my artistry isn't too strong here. The idea that this is the same as this distance, the same as this distance, and so on. So you might have to kind of imagine that's what I've drawn here, but that's the idea, is that you're just showing that they've got a constant width, because remember the width of all our fringe spaces, from the center of the bright fringe to the next bright fringe, that's constant. So we need these bright fringes to have a constant width. Then the idea is that it's symmetrical, so it's the same on this side as it is on this side. So that's another. We obviously need, as we were saying, the idea that in the center you've got a bright fringe, that's a peak. You have a peak for a bright fringe and a trough for a dark fringe. That kind of goes without saying here. And finally, the other thing was the idea that we have this decreasing intensity as we get further away. And it wasn't something you had to show, but we've done it here just to kind of tick every box, but don't worry too much if that really surprises you. Light will get more intense the further away you get from the source. That's just a given. Therefore, you will have this declining intensity, but that's not really a property of the Young's double slit experiment. That's just a property of light itself. The further it gets away, the less intense it gets because it spreads out more. So that's what we find. This is our pattern. So finally, they ask us to observe an interference pattern, the light sources need to be coherent. So we need to explain what is meant by coherent sources. So we've sort of talked about coherent sources a lot by now. We just remember the coherent source or coherent sources emit light with the same frequency and a constant phase difference. That's the important thing. So you have to have the same color light, same frequency of light, or same frequency of whatever wave you're talking about. They have to have a constant phase difference between them. It can't just be changing randomly. So two light bulbs are definitely not coherent because...
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.